Start recording. Okay, so chapter 13, conditionals. So, what are your thoughts on it?
What are my thoughts? Man, it's actually been a while since I read that chapter.
So, I'm gonna start.
Um, I mean, there's not much to it because, like, it's if then else, right? There
Yeah,
are
yeah,
only
yeah, but
so many ways you can
yep.
implement if then.
But I remember at least two things. So, first, I don't consider to be a Chad move to inherit the convention of C. So he is doing that. So zero is false, and anything otherwise different than zero is true. I don't think we should do that, but I have a very statically and strongly typed mentality. So I'm not a fan of that. What I am very interested in though is the fact that you. Okay, so let's go. It's actually down there. So let's go through
Uh,
in order. Go on.
yeah, about zero being false, you have to remember that um, no pointers are usually represented as zero, right? That
And
might be part of the motivation for it. I don't recall if he takes pointers to L vowels or if he just takes the L vowels directly.
we're gonna see that very shortly. So that's
L
okay.
vowel pointer, yeah. Which means that actually what he did is literally say, okay, no's are false.
Yeah, no, but that's what I'm saying. I like one thing is one thing and the other thing is the other thing. So I'm not a fan of like zero and null and false. They are all synonymous, even though they are have very different semantical representations and understanding. Um,
But that's just the thing. The actual number zero, like the actual number zero, uh, is not. Uh, it is actually not represented the same way in C as it is in this Lisp dialect, right?
mm, I don't think so. I think they are being represented differently, but he is also saying that he's going to make a very similar rule to C because he's going to leverage C's equality and operators. Um,
Yep.
but again, I think that if you make like only in the case that doing it correctly and properly is like a royal pain in the butt, which is in this case it's not the case. Aside from that case, I think you should do things like separately and properly, and they have different meanings. They are not you're not exploiting an implementation detail that zero, null, and false are all considered the same. But that's fine. That's okay. That's my comment about it. I didn't like this, but that's fine. So then we make all the comparison operators. That's okay. And again, he's leveraging C's implementation. So that's probably like the easiest way. And because this is the easiest way, you need to accept this.
Oh,
Uh,
okay. Now I remember. I actually scrolled. Yeah, actually scrolled down a little bit and I saw what you were seeing right now effectively.
yeah.
Yeah, he's actually using the actual number zero as false, which I agree is actually pretty questionable.
It is pretty C. Like this is C mentality for sure. But I don't know. Well, maybe that's what he's going for. Then we go to the equality. So now we need to define equality. This is basically like a type class implementation.
Well, no, it's actually literally just a big. I'm not gonna say it's like a type class because it's not extensible like a type class, but yeah, you can think about it like that, I guess.
Actually, it's kind of like a convolution of type classes, right? Because in Haskell, what you would do, you would have like for every single one of these in case and in the switch case, you would do an instance implementation of the equal type class. So they would be geographically separate, and if you condense them in one single block, it's going to be like very similar to this. So he's
Yeah,
basically
basically,
defining equality for all the types.
yeah. Like if Haskell if Haskell had some way of like doing dispatch on the type of a value instead of uh,
Mhm. Mhm.
strictly to just analyzing analyzing some types,
Yeah.
then you could do something like this, where okay,
Yeah.
you have a function takes a value of an arbitrary type, it checks the type and dispatches to the correct implementation.
Yeah.
Uh,
Yeah, you are right.
yeah,
Although this is kind of like bloated a little bit because if I want to take a look in like the XPR, I'm gonna have to read all of this, and I don't really care about it. But again, it's fine. So how are we doing that? So it's very simple. Although something very interesting is that he's defining the equality of functions. That's a big deal because that's not how usually we do that. So if he compares if they are both built-ins, and if they are, then he just compares the built-ins. And if they aren't, then he passes the formals and the body. And I think what he means with formals is like the arguments or something.
it's the argument list. Yeah, he's basically saying two functions are equal if they have the same source code,
Yeah,
effectively.
lexically the same, right? So if the tokens are the same, they are the same.
Which is probably the only reasonable way to do functional equality, because like
Yeah,
what
because
what
alpha
other options?
conversion isn't that a halting problem or something?
Yeah, no, what are the options? One, you can do what most Lisps do and say, okay, uh, let's just do pointer equality. If the two functions are physically the same objects, then we know for sure they are equal. And otherwise, we just give up and say, okay, they are different.
Yeah, I know, but you could alpha convert them as well. So if you have a
The
function
other, no,
and
no, no.
two
The other
functions and
option,
they have two different bodies and two different arguments, if you alpha convert one and you get the other, they are equal.
I can tell you,
But
uh,
I think this is
I
kind of
can give
like
you
a NP or
I can give
whatever.
you I can give you a reason why that may not be desirable uh, soon, but let me just finish my thoughts. The second option for equality is to do what he's doing here and say, okay, two functions are equal if they have the same formals and body, if they have the same definition, effectively, which, okay, that's a much more useful definition of equality. Uh, but it's a very dumb one, right? Because you don't really analyze anything that the function may do. Uh, but you're kind of forced into this definition of equality if you want to have a useful definition of equality, because otherwise you run afoul of the halting problem, as you mentioned.
Yeah, no, that's the thing. I
Uh,
think that doing alpha conversions is not like that sounds
the,
like a halting problem.
the, the problem with alpha conversion is that this is not just the pure lambda calculus, right? This is actually a Lisp. You have to take into account the fact that we may have some meta programming going on.
But couldn't you get around that just excluding macros from the conversion?
But how do you know what's a macro and what isn't? That
Because you have
depends on the
syntax.
environment.
No, you have
That
syntax for
depends.
it. You do. You do know that.
Oh, right. This dialect doesn't actually have macros the way traditional Lisps
Yeah, they
do. It
they
only actually
introduce a
only
piece
has.
of syntax for it.
That's actually still not good for alpha conversion, though, because you may take a piece of you may take something as an argument that's just like not evaluated, but then you call eval on it in some nested call, and suddenly alpha conversion is now lying to you.
Oh, you're changing the semantics if you don't out alpha convert the macro. Ew.
Yeah, alpha conversion in the presence of eval and first class, well, and homoiconicity, it gets messy. Let's put it that way.
Ooh, yeah, that's kind of tough. So I guess this is the best that you could have done. Again, and I'm pretty sure that doing generic, like the general case of alpha conversion, it is some sort of halting problem. So that was just like
Uh,
brainstorm or something.
I don't think just alpha conversion on its own would run into the halting problem if this was like uh very strict, let's stick to the lambda calculus kind of language, which Lisps actually are not, because they like to play around with syntax and environments and evaluation, which are actually kind of outside of the realm of the lambda calculus as it is traditionally studied.
That makes sense, I guess. Okay, and then in the case of our XPRs, both the macros and the normal ones, we just iterate through all the things because they are basically lists, so that's fine. Then we also implement the comparison built-in. Uh, what is Nathan saying? To know if two things are alpha equivalent is quite easy. If they compute the same thing is the problem. Mm, are you sure about that, like in a general case? Because don't think about a very like dummy identity lambda, Nathan. I'm talking about like lambdas within lambdas with clashing of naming maybe. Like again, maybe I am overstating it, but again, that's just a brainstorm idea. Then he's
The
making
problem,
go.
well, the other problem with alpha conversion is that alpha conversion actually fails to capture an important thing, which is the environment in which you are evaluating things, because like the environments are mutable, kind of, right?
Mhm.
So alpha conversion and then compare um, will actually tell you that two functions are equal when they may behave differently depending on the environment that you evaluate them in.
But I would say that like that's a stretching a little bit because yeah, it depends on the environment, but that's like extra realm of what does it mean to be equal. Because right now we are just basically checking are the tokens the same? So,
Well, yes,
eh, eh,
that is that's basically the most. I think that's a very reasonable way to define equality of functions because it's like it's the least effort for the most accuracy, I would say.
fine. Again, I never encountered a situation in which I wanted to compare two functions. Like really. Uh, but if I wanted, maybe just like the tokens being the same would be enough. Hard to tell. I need to think about it. But again, the alpha conversion suggestion was basically like a different idea of what does it mean to be equal. Because if I have two pieces of source code that are different, but they are producing the same output functionally, they are just
Uh,
one alpha conversion away from being the same. Is wouldn't that be useful as well? I don't know.
you also have to keep in mind that scoping is broken in this language, as we already established.
Yeah, that's true. But I forgot about that. Hmm.
Uh, Reference equality is like a conservative approximation of syntactic equality, which is what we're doing here. So, um,
Anyway, so then we are defining the comparison. So we are defining if we are having equals equals or different or whatever. Then we have this is basically like an internal thing to allow these things to be available. And then finally go to the if function, which is very interesting because he is leveraging the Q expressions, right? Because he's basically saying, right? He is basically saying that we're only gonna evolve the path that matters. So we check if it's a boolean because you can in here. Um, then you just ask to evolve the then branch or the else branch. And then you delete the remaining, which means that the sequence of tokens that made the branch that you are not going to, it's just discarded. So it's kind of nice in that way. Uh,
Oh, but it deletes it after it calls eval of the branch that it chose.
Mm-hmm.
Ah, yeah, that's kind of bad. It prevents a potential tail call from being here, which is not something that the implementation is concerned with.
Not now,
But
because chapter 14, he's gonna say, now we are done, let's make improvements on it. And maybe the improvement is tail call.
isn't that like chapter? I'm pretty sure tail calls are mentioned in chapter 16, which is the bonus projects.
No, that's the thing. So chapter 14 is the end of the core language, and after that, he's gonna make a library in chapter 15, I believe, and then chapter 16 something else. But this is preventing tail call. I think that's true. Then we just add the built-ins for ifs and equalities, operators, and stuff like that. And then now we have enough built-in stuff to have recursion, apparently, allegedly. Um,
Well, yes, the thing that you were missing before was a way to stop the recursion, right? Otherwise, recursion is not really useful. You just repeat forever and you never
yeah,
return.
yeah, that's true.
But now we have conditionals, so we can actually stop the recursion, which is nice.
Mm-hmm.
So now we can. This is the language code, right? Which is kind of blows your mind. So this
Can
is
I say that I don't like the fact that he put some closing delimiters on a line by themselves? That's not Lispy at all.
well. What do you want me to say? The guy is doing a Lisp in C. Come on.
Also, the open curly brace up there on a line by itself, that's also not Lispy at all.
That's very C. That's very C. Uh, okay, and then we made the length function and the reverse function as well. And he also gives us a spoiler because now that you know how to stop stuff, you can have loops. Hmm? Very interesting.
Yes, but to have loops, but to have recursive loops and proper recursive loops, they have to be tail uh, tail calls, which we already established if currently doesn't support tail calls because it calls delete after calling eval.
I think you can make a very grug while loop or for loop using this and recursion. I think you can.
You totally can, but you need, as I said, proper tail calls. Otherwise, you'll have problems.
Such as?
Blowing the stack, for instance.
I think he's fine with that. That's true. Uh, okay, and then we go to a very interesting chapter, if you know what I mean. Which is in developing is fucking strings again. The same goddamn problem every single goddamn time. And of course,
Memories, memories of chime
yeah,
here.
yeah. But here's the thing: he has the solution. Have you noticed this? He has a solution to that problem. Whatever his magical function does, we can try to copy or implement it ourselves based on it. Huh? He has a solution.
Uh,
Amazing. Uh, so again, this is a new type. So that means going to the enum, bloating the lval stuff again, and then allocation, deletion, printing, all that nonsense every time. This is actually a good summary of the boilerplate that we all have to go through when you need to add a new type. You need to do
yeah,
all of these every time.
and the solution is not really applicable because we're not using the same library that he is.
Who cares? You can read it. Who cares?
Okay, that's fair enough. That's fair enough.
Um, Okay, then he also here's the solution. So he has this. So whatever that is, we need it. That's the conclusion. We need it. Because our strings in Chime they don't support escaping sequences. You can write them, but they were just gonna be the backslash and whatever you put afterwards. It's not gonna be like new line or whatever.
Yeah.
Yeah, pretty cool. So then he goes through all the. This is a good reminder actually of what you need to do to introduce a new built-in type to the language. So
I just had an idea, and I'm not sure why I didn't think of this before because it's kind of obvious, but we can actually sidestep the problem of escaping new lines in Chime by just saying, okay, here's a new piece of syntax. It allows you to embed an arbitrary file as a string in the middle of your program. Go nuts. And then the file can have whatever we want because it's a separate file.
yeah, that's kind of what he does in this chapter, right?
No, he actually uses escaping, like proper
No,
escaping.
no, no. But what you said, because the first thing that he did, actually, it's a very interesting choice of sequence of features to implement once you have strings. So he implements strings, so he does all the boilerplating. That's fine. His first instinct after doing it, he, oh no, this is to introduce to the REPL environment to be able to the user to use it. So now you can create strings. So
Let's
here's the example.
let's
He, but his
let's not
first
skip ahead.
his
Yeah.
first instinct was comments. Hilarious, because like, what a moment to decide that, you know what? Let's add some comments. And then he basically goes that. So he introduces a new definition in the regex, sort of like a parser generators thing. It's a parser generator being implemented using parser combinators, reminder, which is again hilarious. Um, and then his first next step is to do what you said. What about
Uh,
having a file as a gigantic string?
Not quite. What he's doing here is a function that loads a file, as in reads and evaluates it, right? And the
Not
intended
only
use
that, it
case,
prints the expressions.
yeah, and the intended use case here is to load libraries, usually, right?
Sure.
That's not that's not quite what I suggested. What I suggested is something that allows you to embed a file as a string in the middle of your program.
Oh, okay. So you want like define a string. That's kind of weird actually. So you pass like a path, a file path, and we read it and we concatenate with your string. And then you would
Yeah,
put the escaping sequences in a file?
no, you don't need escaping sequences because the file is a separate file. It's not gonna get parsed.
No, 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 no.
You can just
You don't
you
understand.
can just have
You got me wrong. I'm not saying that you're gonna parse the file. You're gonna read it as a gigantic string, right? And then you're
yes.
gonna append it to the whatever came before from the user. And then you don't have to care about escape sequences because it's already been kind of handled by reading the file as a gigantic string.
Yeah.
But that sounds really inconvenient because if I want to say hello slash n, world slash n, I'm gonna have to put two file paths to do that. Like,
No, you just have to have one file that has new lines in it.
oh, so oh boy, but that's weird. You need a file to put scaping. Only scaping.
No, you don't need to put escaping in the file. You just write whatever you want in the file, and it may include new lines or other characters that you otherwise would need to
Yeah,
escape.
but what if I just want a string in my chime program? I need to do all that nonsense now. Yeah.
No, but the idea here is to work around the problem of wanting to escape
That
characters,
is
you
that
see.
is true. That is a workaround around the problem of not being able to properly handle escaping sequences, but I don't know if it's a great one because You
It
are
has other
adding.
use cases as well. It has other use cases as well, such as say you actually want to have a file, like an actual text file embedded in your executable. You can do that with this,
You can print a meme in text format in Chime.
I
Hmm?
guess.
Huh? Huh? Come on. you can
Yeah,
you
yeah,
can pick a meme, pass to those generators that transform them into text, put that text in a file, and use the syscall to std out to print the meme. Huh?
yeah, you can. Anyways, this is a tangent. Let's get back to the book.
Yeah. Um, okay, so then he allocates stuff to be able to create a string in the L val, like lifting to L val, right? Um, then we have this is basically pure now that I think about it. Fine. Uh, and then you have deletion, you have being able to copy, being able to also define equality now that we just defined in previous chapter. The type name, I think this is for the purpose of printing, pretty printing. And then how you print it. And this needs to get around the quotes, I believe, and stuff like that. Yeah, definitely escaping the quotes, removing the quotes. Then this is to be able for the user to use it, right? So this is the internal gears, like internal mechanism of the language, and this is for to the user to be able to use it. So then he is basically cutting off the final quote and doing all that stuff, also passing the magical function to get around the escaping problem, um, and then creating the string here, like lifting to lval, and that's it. And then a few examples in here. Now we go to comments, which goes to my next question. Do you know the reason? He says that he doesn't know the reason. Do you know the reason that the comment is semicolon instead of whatever?
Um, I'm pretty sure that the reason is because back then, usually you wrote programs in assembly, right?
Sure.
Because like there aren't many languages to choose from. You have Fortran, and like that's basically it, right? So usually you would write programs in assembly, and assembly traditionally uses semicolons to start the comments.
Oh,
So that's probably where the convention comes from.
okay. I didn't know that. So basically, this is basically adding regex that jumps everything until you find one of those. So, and then
You
he,
have to remember that Lisp actually has a very strong influence from assembly languages because like R and CUDA were actually instruction names back in the what was the computer that they were using? Some old IBM architecture. I don't recall which one. I think it may have been one of the PDPs.
okay.
The PDP 10 maybe? I'm not sure. I don't
Mhm.
recall.
I see. And then we go to the load function, which is basically a way that now you can have a file. So the abstraction of a file, because right now we were only using the REPL. And something also that he said, which I think is interesting, is that I never thought about it, but it really makes sense that comments only make sense if you have files. Because if
Yeah.
you only have the
Why would
REPL, what would be the purpose of that? Aside from
yeah, why
teaching,
would
I guess. So,
yeah, there's like the shell has comments, but we never use them when we're just typing stuff at the terminal, right? We only
yeah.
use comments when we actually have a proper shell script.
Yeah. So that's interesting. I never thought about it, but it makes total sense now. Um, so then we go to the load, which again is the remaining abstraction so we can have files now, which again, as Marinho said, is for the purpose of having libraries. And we gonna use the eval read that we were previously using when using the REPL. So that's also very nice. It's very nice that he made pieces. I don't know if he did this on purpose. No, for the book part, for sure on purpose. But when he was making the language, he thought about it. Like, I'm gonna make this eval read stuff being expression based. like one line at a time. And then when I'm having a file, they're gonna be just a sequence of them, and then I'm gonna have them for free. Sounds nice, but I don't know if you thought about it. Also, now he cares because we are at the point that we are getting around, not getting around, but you not only have the REPL to do development, you also have some sort of like an executable that you can call, and that's going to load a file. So you need a file path, and the way that's going to do that is via command lines, which is kind of funny because that's exactly, kind of like exactly what we did in the previous Chime session. Um, Ours is a little bit fancier because you have extra options. You can save the program, you can load the compiled program, which is not what he's doing. Um but it is kind of the same idea. So you are basically argv and argc for days and just loading it in order. Um, yeah, you're basically loading them. And you are printing them, as I said. You're not only evaluating them, you are also printing, which is interesting. Um, Next thing is um, okay. So it goes about that printing function. So I don't remember why do we need this. These are extra built-ins for the user to have. So you have print and error. So this is a printing function for the user, and this is an error function for the user. And then you just add them to the built-in list, and here we go. Now you can print stuff. And actually, these open close parens.
That's
Um,
because it's returning eval as expression, but it's empty. It's literally returning an empty list.
oh, okay. I haven't noticed that before. Okay, that's good to know. And and then apparently that's it for the whole core of the language. So basically, in these two chapters, we add conditionals. We added equality, all the other comparison operators. We also added ifs, which is already enough if you're not optimized tail call, but it's already enough to make loops for sure. And now we have strings, which and with that we also have uh, comments. He did in the same chapter for some reason, and we also have strings with escape sequences, which is also nice. And we also have the ability of loading files now. And that's it
Yep.
for the core language. That's his words on mine. So because we finished very very earlier today, like 33 minutes, let's take a peek on what he's coming from for us. Uh, so atoms, that's interesting. I don't know if this is like closure atoms, but
No, no, no. Closure atoms are different from what's traditionally called atoms in Lisp. In Lisp, atom and symbol are actually synonymous. Uh,
mm-hmm. Then we have some unpack, pack, curry, and curry stuff.
I find it funny that he's defining nil, the symbol nil, to be the empty list. That's like
That's not empty
what?
list.
Oh, it's actually the empty. What did he call?
Q expressions.
I know that's the term he used for like
That's the macro.
expressions that don't get evaluated.
Yeah.
But like, what does he call? Would he call the? Hmm. Oh, he literally says. Okay, that's a reference to traditionalist. Never mind.
The heck is this? Can you hear this?
I heard some noise, but it's over now.
What the heck? Anyway, then and we're not gonna read it right now because that's for like next session. But we are just like a peek of what the heck we're gonna be doing. So basically, logical operators, flip. What the heck is ghost? It's already based. It has composition. What can I say? Um, but what the heck is ghost though?
It does nothing. It's effectively a thing that doesn't exist because you say ghost and then you say plus one two, and that's the same as just saying plus one two without the ghost. Like it evaluates its arguments as if you just typed the arguments without the ghost at the front.
But why would you need that? What is the use case of that?
I don't know actually. It's not obvious to me.
Yeah, here's the example that you just said.
Well, it's because I actually saw the example. So
Ah, these functions. Okay. Many. I'm 100% sure, like just to the meme, they're not gonna have chunk by size because nobody does.
why would
Nobody fucking does, dude. Uh, but they do have split at. Wait, but is the split at that we implemented ourselves the one that like no, that's chunks by list. I think split at is this one actually. And they have it, and Okemo doesn't. I think Okemo was the one that we implemented that.
And they are proud of that.
Ah,
like
amazing.
I can I can see why would be proud of having a minimal core. I don't see any reason to be proud of not having a decent standard library. Like why?
And this is funny. Like I never thought about it, but in his language this is possible, right? Nothing is preventing you from doing this. You can literally do a minus one. It's basically a map multiply minus one, but because the way that it works is so different, you can just do this.
That actually works in any Lisp. Like because minus is variadic, right?
Yeah, no,
You
I
can
know that.
you can treat it, which means you can call it with just a single argument. And when you call
Yeah,
map, you need a function of one argument.
yeah.
And if you call minus with one argument in Lisp, traditionally that's the negation function. So,
Yeah, no, and in Lisp I know that the minus is variadic. It's just funny to me that it never occurred to me that you could do it like this.
well, you can. Now you know.
Filter, foldel. We also have sums and products. That's really nice. Thanks for
And
the
knowing
indices.
is half the battle.
What?
And knowing is half the battle.
Yeah. Select otherwise. We also have case. Now he's implementing Fibonacci. Really good. So this chapter is kind of long, but I think I want to analyze if it's worth to read that aside from the bonus. So macros, pool allocation, garbage, tail call optimization, conclusion. Okay, so I guess we have one last session then. Chapter 15 in the bonus.
Yep.
Okay, that's really nice. So yeah, here we have the credits. Okay, so one last session, and we need to think about what we're gonna do about it because remember, Edu asked us to do an improvement on it. So probably doing one of these, or something that we notice, such as the scoping.
That is
Uh,
the scope. Yeah, the scoping is. And the funny thing is, traditional Lisp, traditional Lisp had dynamic scoping because of a bug, actually, and it
I didn't
stuck.
know that.
So, although it saddens me that this also has a dynamic scoping bug, it doesn't actually surprise me.
Okay. Okay, so I'm gonna finish the recording now. 40 minutes. I think that was great. We covered everything. We talked about it. We also now we are aware that we can fix the escaping problem. with whatever that function does. We're gonna have to read it and understand it, and probably re-implement it to accommodate our needs or something. That's nice. So I'm gonna finish the recording now.